Good morning. I am Prabhu Venvarad, Assistant Professor, Department of CSE, BADCT, Vijaypur. In this lecture, I am going to discuss about input modeling. So the contents are data collection, identifying the distribution with the data, parameter estimation, and goodness of fit test. So let us first understand why input modeling is required. Input models provide the driving force for the simulation model. So as we have seen already, different simulation we have conducted by considering queuing systems, inventory systems, and reliability systems. So there already we have used input models such as the distribution of time between arrivals and service time, and demand and lead time, and distribution of time to failure of components. So all these data whatever we have considered is adequate input model already developed. So in real world simulation applications, coming up with appropriate distribution for input data is one of the major tasks from the standpoint of the time and resource requirement. So regardless of sophistication of the analyst, faulty models of the input always will lead outputs to misleading recommendations. So that's why to avoid misleading recommendations, we have to model adequate input models. So there are 4 steps in the development of useful model of the input data. So they are: collect the data from the real world system of interest. Here this often requires substantial time and resource management. Sometimes unfortunately it is not possible due to following situations. So when the time is extremely limited, when the input process does not yet exist, and when the law or rules prohibit the collection of the data. So in such a situation, we can consult experts who are actually involved in a system and take a opinion and obtain the knowledge for making a educated guesses. The second step is identify a probability distribution to represent a input process. So when the data are available, so this step typically begins with the development of a frequency distributions or histogram of the data. So depends upon frequency distribution and structural knowledge of the process, a family of the distribution is chosen. So third step is choose a parameter that determines a specific instance of the distribution family. So when the data is available, so we have to select a parameter estimator for a particular distribution. And fourth step is evaluate the chosen distribution and associated parameter for goodness of fit. So the goodness of fit can be conducted by using informal methods, some of the graphical methods, and formal methods. So where the statistical tests are used, so they are Chasquet test and Kolmogorov-Smirnov test. So in case of checking a goodness of fit, the chosen distribution is not uh, give a good approximation of the data. Then analyst return to the second step, and he or she can choose other family of the distribution and repeat the procedure. So after running several times, even if the procedure fails to yield fit between an assumed distribution form and collected data, then the empirical form of the distribution may be used. So let us summarize the steps of development of useful input model of a data. So first step, we will collect a data from the real world system. Second step, identify the probability distribution to repeat the input process. In third step, we will choose appropriate parameter estimator of a family of a distribution. In fourth step, we will evaluate the chosen distribution and associated parameter for goodness of fit. So once if the goodness of fit is approximate to the data, then we will stop. Otherwise we will repeat from the step 2 by selecting the different family of the distribution, and we will repeat the steps.